Hi, this is Dmitri Arkhipov. This is my report for part 2 of the project. It's December 5th right now, Monday of finals week, when I'm recording the demo. And this is as far as I was able to get. I'm gonna give an overview of the features and explain them. So, as you remember, I was working on the M project by Arjun, your student. And this is the screen that comes up when I do a select all query on his images. This isn't all of them exactly because there's a limit, but as you can see, it's a good start. Quite a few images here. I think what it's set to right now is a couple of hundred or something like that. Um, okay, I will start off by showing some of the differences between what Arjun used to have uh, and the current user interface. So first of all, the search box was the only thing that came in here originally. I added 2.5 features, which is most of what I wanted to get out of the project. I didn't quite finish 100% on the geographical portion that I mentioned in my report. So I'll start off by showing some of the time features. Here's these 6 boxes down here represent the time anchors. You have a start anchor and a stop anchor, and it chooses everything in between these for the images. I'm going to show you here the start year, start month, and so forth. So one of the major parts I think I did for this project is the user interface for these start and end years. By default, nothing is set, obviously, and that means take the full set of images returned. Now, if I want to specify a start year or an end year, I can do that. But as you can see, you have no options for start month, end month, start day, end day, none of that. Which makes sense because you need a year to have a month to have a day, right? So let's say I arbitrarily chose the year 2001 to start. Arjun only has pictures from 2010 and 11. I should probably mention that these are Arjun's pictures, not mine, so you may see yourself in them. Let's go ahead and pick the start date is 2010, and I'll show you right now that the end year is now only 2010 2011. This is because it automatically updates all of these boxes each time you update one of them. And what this does is it doesn't allow you to pick days that don't exist, months that don't exist, times that haven't happened yet. None of that. So it requires basically no input checking at the back end. Although it may be safe to do that anyway, but I don't. So as you see, I have all 12 months, and the same would happen if I have 2011, but if this happened last month, you wouldn't see this 12 here because it keeps track of that. The system will only let you enter a month that has actually occurred. So let's pick a month, let's pick 2, and let's pick a day. Well, no days. And then let's say we only want all the pictures from the second month of 2011, including all the days. And let's say we're going to search that. And this will bring up all the pictures. I'm not going to bring up the image data because the version I'm running doesn't have a nice way of doing that, but I checked it and it checks out. This is all of the data from that second month. Let's see if I can narrow down the days. So let's go from the first day to the 5th day. Same month, same year. So these are all the photos that we're taking between 1 and 5. So I'll use this as an example to show you that you see when all 4 of these are selected to the same date, you can only choose 1 through 5 here because your 5 at the end date limits the number of days you have to start with. So if I change mine to 10, I can go all the way up to 10. This would mean that I want only a day 10 on that month, on that year. So let's see if there's anything. Yep, these are all the 4 photos that were taken during that day. Okay, so let me show you this. That when you go to 2010, and you can do the same exact thing. You can choose between days and months, and when you have 2011, you can, let's say, 4. Uh, then here. So this means everything from April to April of these 2 years. And let's choose day 1. There should be quite a few pictures here. There you go. So that should show the user interface portion of this. Basically, starting from my point of doing some semantic analysis on the language, that turned out to be a bit too hard, so I decided to encode some of these statements that I was going to parse in the natural language, in particular these date and time statements, in JavaScript, and this will allow you to elicit the same behavior as I was expecting, but it forces the user to choose to pick the dates manually rather than enter them, which is less nice but a lot easier to program. And I've looked around. I couldn't find anything that particularly does this, that allows you to only enter the correct date and remove the need for validation at that end. So this was entirely, I didn't use any libraries, I just did it in straight JavaScript. So then I'm going to show you here, this is the exact same sort of aspect, but with geography. You've got United States, you've got California, and you've got cities here. Oops, well that's a statement I forgot to comment out. This information that you pick here is going to get uploaded to the server, and it's going to get sent to a filter, but the filter isn't going to do too much with it because when I was doing this last feature I sort of ran out of time. So these text boxes, they all look exactly the same. My idea was to filter out the data from 2 ends, basically time and date, and then I can remove all of those things from the search box so that I can do the data appending I was talking about in the queries before, and that I was actually able to get done. So here we have date and time, and the date and the geographic location. And the geographic location doesn't quite work. I'm sure I could get it working in a couple more days, but that's a couple more days I don't have. So let's start out by doing some keyword searches. I'm going to pick a set of photos that I've worked with before so that I know roughly what kind of behavior I'll be expecting. So I'm going to use this month, and I'm going to use this date setting. Before I move on, I should probably mention you can only set the start and without setting the end, and it'll do what you'd expect and basically consider the end is the end of time. Similarly, you can choose a year and a month but not a day. That'll work. I'll show you real quickly. It takes a second. There you go. So this will be all of the months between 2 and 3, so 2 and 3 inclusive, and the days aren't unfiltered. Okay, so getting back to the query storage, right? I'm going to choose 2 here, start date, and then let's go to 12. I'm going to say I've looked at the metadata for some of these pictures, so I know a certain picture set. I'm looking at these 2 pictures and on some of these. I'll show you what I'm going to do here. So let's say that I want to query Costa Mesa. So I'm going to say Costa Mesa. This is, right now, this is going to be Arjun's original data. This isn't anything I've done. It was part of his original search function. So let's see what happens. Okay, so let's do the Costa Mesa query. There we go. So what we've got here is we've got 5 photos. I'm not sure too much of the event, but we've got a car here. We've got a lady driver with a pink jacket driving a red car, and we've got some kind of strawberry dessert, and this guy here eating it, who I don't know. But I'm gonna go on a limb here and say that these things are related. That you guys probably drove this car with this woman to a restaurant, and he was one of the people who went, and you all guys all ate. So this Costa Mesa is going to is going to bring all of that up. This isn't any metadata I've added. But if I say something like, we went to Costa Mesa in a red car, ate strawberry dessert. Let's see what this will give us. Now, obviously, the point of this is isn't to get more specific on these pictures, but let's say that this was our original query. Then the Costa Mesa part of it is going to get you the same data set, but the other parts are going to associate with these pictures, like what I had described in my report. And so now I should be able to, after executing this query, I should be able to recall these from any of the other keywords within here. Let's go with, I'm going to assume this car is a Jaguar, just because I already did car. Let's do that. So as you can see, the same pictures come up. Strawberry dessert, all of that. Now, again, that doesn't really show very much. I just entered a natural language query, and it brought up the same results as if I just entered Costa Mesa, which was in the pictures to begin with. So the part that is unique, I'd say, is that now if I take that out, and then let's say I don't even remember the date, I don't remember anything about it at all, but I entered that query at some point, and it's years and years later, and all I remember is that we rode around in a red Jaguar. Okay? What's that going to give me? Well, it's going to give me some other pictures, because probably of this road term. But this red Jaguar, all of these things come up, and they wouldn't have otherwise. There's no reason for them to come up. I'm not quite sure what the association was with these pictures, but I'm sure that's in some of the metadata as well. The point is, it's very doubtful that these would have come up before, because there's nothing in the metadata to suggest Jaguar or any of that. So that's the main advantage here. This keyword association, query association, will work whenever there's a small enough set, and right now that's hard set at 8 pictures. That's just a number I picked pretty arbitrarily. Let's show one more thing here. Let's say I do know that the year is 2011, but I forgot the month. Now, if I do know that much, and I enter it, I'm gonna get a few pictures less, as you can see. I think this would help a lot more when there's more years of pictures, but as you can see, a couple of them were eliminated anyway. I'm going to show probably one more example. This will be somewhat free. So let's see what Arjun took without any terms in the month of December, which should be pretty topical. Well, he didn't take very much. So let's go to November. And before that, okay, so we have a concert here. These are probably all going to be on the same day. Let's see, between 1 and 9 and 17. Here. So let's try another month. Let's try another month. Let's look here. And no pictures on that day. Okay, we got some pictures here. This is all the same event. So we have a couple of events here, it looks like. This set here is probably separate, and then this whole set here is probably separate. This first set is going to be too many pictures to deal with because of my constraint at 8. This set too, where we've got some tires going on. This set here might be okay. Let's see if I can identify. Okay, well, I found a different set. Let's use that. This is some kind of paper. So I'm not sure. I haven't actually seen the metadata for this one. I'm going to okay, I'm going to continue. I just looked up the metadata for these pictures, so I have something to base this on. It's a bit difficult when they're not mine. So this is an Irvine, I'm guessing UCI, so I'm just going to use that as a keyword. I'm going to say Irvine, and these same things should come up. And they do. And we've got these dates here, so that's pretty selective. Let's say my original query was, or let's say studied information. You see Irvine. Okay, so let's look that up. Again, we're gonna get the same thing, I think. Yep, we do. Okay, so the metadata here had been completely unedited. That previous example I'd looked at before, this is a completely new one, so all of these associations are going to be new. So let's do this. Let's take off any of that, and now we're looking at the whole month again, what I was doing at the start. Oh, I need to put a star. And we have this whole set of pictures again on this month. And there we go, we have these two here. Now again, let's play this game of I don't remember what month it was, I don't remember any of this. If I do a star here, I'm going to get all the pictures in 2011, which is basically half my data set. It may take a second actually. Or more than a second. Well, there you go. It's gonna keep loading them. Right, there it goes. It's just gonna keep loading and loading and loading. I'm going to just let it go down and explode here. And through all of this, somewhere in there are gonna be these pictures, and I can't even find them now. So let's instead, and this isn't even all the pictures. This is just I think 100 or so. Let's do use the terms we put in during the query. So I remember that I studied something. I don't remember anything except the year, and the papers come up. Now, if I did this query next to those pictures that you probably saw of the whiteboard, then 4 pictures would come up: the paper and the whiteboard, and they'd belong to a different event set. But they would all be associated with the keyword studied, because that would be the query that I used. Let's do one more shot here. There you go. And just to show off, I'm not gonna run the full query, because that's just too many pictures and it's pointless. I've shown you already. So I'm just going to say run this whole query with information retrieval, and they still come up. So that's the idea. I think I've shown enough example of this, but it's just like what's in the report. The keywords are extracted. Lucene does the stemming automatically. I don't. If I had a bit more time, I'd stem the words as well. Maybe throw in a little bit of semantic analysis for the language, and try to put in some weights on matching these things based if it's a verb or what part of the sentence it is. Right now, all it does is keyword matching and keyword association. But I think from the examples I've shown here, both of them, it's even that limited functionality is pretty cool. So let me show this last thing I did. I was talking to Arjun about this, and he had an idea that I really liked, so I tried to implement that. His idea was that what if we had a whole bunch of these natural language sentences, and we wanted to associate them, do my program basically in batch mode, and you wanted to take a sentence or maybe a couple of sentences and say that that's a contiguous idea. It's its own query, and whether it gets associated or not depends on that query in isolation. And then the next sentence is an entirely separate idea, and it should be its own query, and these things should be displayed in a way that's relevant to the user, so that each sentence will map to an execution. And this is gonna explain this line that you've been seeing down here. I was able to code that up and basically get a batch mode for this system, which is another sort of user interface perk rather than a backend issue. So I'm going to show you this multi-query feature. I haven't tested this before due to just not quite enough time, and whenever I test it, more words get associated. So unless I want to rebuild the whole database, there's not going to be too much testing. So I'm going to enter, I don't know, 4 queries. I'm going to put 4 dots here, 3 dots, and I'm going to enter the queries we talked about before. So I studied information retrieval at UCI with my colleagues. And then, not a very good speller. And the next we'll have I had dessert with my friend, comma, it had and that should display at least those 2 groups we talked about here. Let me do 2 more real quickly. These oh no, I'll do this. I drove my red Jaguar, and here I'm going to say at Arjun's I just made that last one up. I have no idea what's going to come up, and the event it refers to didn't actually happen. So let's see what comes up. We have a couple of queries that should show you a lot of it. It may take a second because we're doing a lot of queries, but this should be the last demonstration. So let's run it on every year from 2010, even though that shouldn't do too much, and 2011. So all the years we have photos for. This may take a second. Here we go. It's loading. Just give it a second, please. As you can see, this is a lot of photos. There we go. So now the problem we have here is that I entered UCI, so that's going to bias this first group because it's going to have everything that has UCI in it. What's interesting is if this was a small enough set, colleagues would get associated with all of these people. So if this was a little its own event, all of this would get associated with the word colleagues, but it isn't. It's too big. So my system assumes it's a not very specific query. But regardless of that, these papers are going to be in it. I'm not sure whether UCI was associated with these to begin with, but it is. But information retrieval is. So here we go. And here are some whiteboard shots that if I selected maybe this whole group, by knowing some of the metadata, I could associate a couple of words with them as well. And here we go. This is that second shot. This should look familiar. We have Jaguar coming up. Actually, this is actually two here. We have the Jaguar associating with these guys. That's going to give you the strawberry dessert that I entered. This is my colleague here. And now let's look back at the second query. I had dessert with my friend that had strawberries. So now because there's only a couple of photos here, this is going to get all associated with the word friend and strawberries. So while strawberries only actually appear in this picture, because it was a contiguous event series, all of these pictures will have the word strawberries associated with them. And let's see, what's the next one? I drove my red Jaguar. So the red Jaguar is going to bring up those pictures I talked about before. These pictures again. Red and drove are bringing up a couple of these things. I'm not sure what the metadata associated with them is, but as you can see from before, Jaguar got associated with all of these pictures, so all of these pictures are coming up again. And what's this one? Let's see. This is the wild card I threw out here with went to Arjun's house, and this is going to bring up a bunch of pictures from Arjun's because it's his username from Arjun's profile.